Okay, sorry, some technical difficulties on the last one. I lost my pen, so we had to end it. And I just asked Mr. Tilton to help me get my pens back. So here we go. Okay. We're going to work on end behaviors of graphs. Okay. End behaviors of graphs. So, in general, here's what you need to know. I'm going to break this paper up into two equal halves. Okay. And over here, we're going to talk about polynomials that have even degree. And over here, we're going to talk about polynomials that have odd degree. Okay. Now, every polynomial with an even degree, meaning that the largest exponent that you see is even, in general, has the same exact shape as a parabola as the most basic even degree graph, x squared. Okay. Here's what can affect that graph. Okay. A parabola is usually shaped like this. All right. As the degree gets higher, staying even, like let's say that we went to something, and let's say that there's a lot more stuff going on, like meaning that there's more than just x to the 6th. There could be like x to the 6th minus 5x to the 5th plus 8x squared, okay? But as these things get higher, what happens is that there might be more loops and dips and valleys in here, okay? But notice that the general shape is still the same. This is just a parabola with more little hills and valleys in the middle. And if it got up to something complicated that was a 12th degree, okay, maybe there'd be a lot more dips and valleys. Maybe it would look like that. Okay, but notice that the ends, the left side are always going up to infinity, the right side's always going up to infinity. Okay, so if it's an even degree, and the leading coefficient, the number in front, the leading coefficient is positive, then it's always going to, in general, be shaped like a parabola, meaning that the ending behaviors would be up on the left. They always list left side first, then right side. The left side's going up, the right side's going up. Now, what we know about our work with these graphs anyways is that if the leading coefficient was negative, now that's not shaped like a U anymore. That's now shaped like an umbrella. So now the ending behaviors, left side first, are down, down. Okay, and again, maybe it looks like this. Maybe it's like an x to the 36th, and it's got all these humps and leaps and valleys, but look, it's still down, down. Okay, now anything with an odd degree is going to be in general shaped like the most simple odd degree, which is x to the first, or x. Okay, that is a straight line. Now, as those odd degrees get larger, again, there's more peaks and valleys in there. Like, for instance, even the graph of x to the third, it looks like this. But notice, yeah, there might be this little turn in here, but see how even on my line, the left side is pointing. Let me change colors so I can, the left side is pointing down, and the right side is pointing up. Okay, so all odd degrees that have a leading coefficient that is positive will in general be shaped like this, or it could be like this. Okay, but in general it's shaped like that line whose ending behaviors are left side first, down, and then up, right side up, left side down, right side up, down, up. Now, if the leading coefficient is negative, then that's no longer a line that has positive slope. It's a line that has negative slope. It's like this. Okay, or if it had more peaks and valleys in it, if it was something like an x to the 7th, then it might be shaped something like this. But notice that the left side is up and the right side is down, up, down. Okay, let's do a couple of these together so I can make sure that I feel like you are understanding this. So I am about to just make up a couple random examples here. Make up some random examples. Here we go. Let's say I had this problem. This is an 8th degree trinomial. The highest exponent I see is an 8. It's an 8th degree trinomial. The leading coefficient is negative. Since it's an 8th degree trinomial, it's in general shaped like a parabola. It's either shaped like a U or like an umbrella. And yeah, there's more dips and curves and valleys, but it's generally shaped like that. Since the leading coefficient is negative, it's shaped like an umbrella. These ending behaviors would be down, down. If I had something like this, 4x to the 5th minus 12x to the 4th minus 6x plus 8. This is a 5th degree polynomial. The largest exponent I see is a 5. Okay, that means it's either shaped like this or like this, a line with positive slope or a line with negative slope. The leading coefficient here is positive, which means it's shaped like a line with positive slopes. The left side is going down, the right side is going up, down, up. All right, that's all I got for you. I'll see you tomorrow in class.